Now we are understanding sound production. All concepts related to this will be covered in this lecture. In this slide. What is a sound? Sound is simple. Whatever we hear, sound of a fan, sound of a vehicle, sound of I am speaking. It is also sound. Okay, there are a lot of different sound. Sound of an animal, sound of lion, sound of elephant, sound of ant. All these sounds are different if we see carefully. We hear this type of sounds. All these are sounds, and we are going to break down it. That's it. We will understand what is the meaning of a sound. I told you this is sound. In details, we will be exploring propagation of a sound, production sound, wave, longitudinal, longitudinal. This is we will break down wave. What is a compression? What is a rarefaction? What is a particles? All this we will explore. There are a lot of things to be covered. To be covered. Now let's start a sound production. How does sound come? How does the sound come? By vibrating. When a object hit to surface of other object, then vibration comes, then sound comes. At the same time, sound comes. It happens when a object when a object will be heated to another object. For example, you can listen. So I took this object and I considered this as object. I am hitting. Sound is coming. Also vibration is happening. I know you cannot see it is an invisible thing. Awaz is not an invisible thing. It can be felt. Sound can be felt. Can be felt. You can hear sound. Okay. Vibration cannot be seen. Yes, it is true. But we can observe only. We can observe. If I hit on this surface of this object, then what will happen? Particles will be disturbed. Particles disturbed. Particles will be disturbed. As I will hit this object on this object, then particles will move like that. Like that. Okay. When I will hit, then particles will move. Of course, like that. So these particles are moving is what propagation of a sound. Propagation of a sound. Let me figure of particles that were moving when I hit the object on the surface of other object. For example, this okay, clear. Let's say this is object. When I hit a object, this object on this object, then this disturb. This is a disturbation. Here, what happened? Some these particles were in a rest, and these particles came into motion when a object was hit. When a object was hit. When a object was hit on another object, then all these particles came into motion, and this is moving like this. Okay, all these are particles. In these particles, you will get what a wave of a sound, like that. Okay, like that. We will draw figure of a wave of a sound from this from this product. Here try to understand, these are two objects, and when we hit this object on this object, then particles came into motion. Now here you can see two types of area. One area where area is not where particles are less, a area where particles are more. So area where particles are more will be considered as compression. Always remember, compressions is an area where particles are more. This area where particles are less will be considered as rarefaction. Because this is area, rarefaction is area where particles are less. Compression is area where particles are more. Remember this. Clear? Now here, can you say particles are more? Yes, you can say. If particles are more, so of course density will be more, pressure will be more, because particles are more. One point I would like to take first of all. Where is the pressure? Okay, this is pressure. No, here. Where is the more pressure? Where is the less pressure? How will you identify? Yes, if particles are more, of course these particles are coming like that. So here pressure would be more. 10 particles, and here you can see, here this area particles are more. These particles here particles are more. Now we can see here pressure will be more, density is more. Why? Because 10 and both came here, and now this is 20. So of course density is more because particles are more. Okay, that's why particles are more, that's why pressure is more. If particles are less, pressure will be less. If particles are less, then density will be less. Remember, okay? What I am saying? I am saying particles are less. It means particles are less. It means pressure is less. Density is less. Remember. Clear? Now next, if particles are more, then what will happen? Pressure will be more. Density will be more. Pressure and density will depend on number of particles. If number of particles are more, then pressure and density will be more. If number of particles are less, then what will happen? Pressure and density will be less. Always remember. Clear? Now, one point more. This compression is area where compression is area where particles are more. It means it is high. We will consider it as can you say this pressure, this low pressure, there is a low density, more pressure and more density. So of course we can draw a wave from this like this, and we can draw a middle line so that we can find something. This is middle line. Now here this compression. In this compression area, what is happening? Particles are more. It means pressure is more. Now of course this is more. This is highest. It is telling you that pressure is more. It is telling you pressure is more. So now you can say this Wave crest. It is considered as wave crest as we study. This is wave crest. Honest remember. This is what? Wave crest. Top surface of the wave is called as wave crest. This is also wave crest. Now bottom surface of the wave will be considered as wave top. Okay, wave top. Always remember. Bottom surface of the wave. Now this height from the middle to the wave crest, this height will be amplitude. This is amplitude. Amplitude. Always remember. Clear? From this figure, we will find high pitch, low pitch, silence. Based on frequency, we will be finding something. If amplitude is more, then what will happen? If amplitude is lesser, then what will happen? If frequency are more, then what will happen? Frequency are less, then what will happen? We will understand. I would like to tell you here. Remember, if amplitude is less, then sound will be soft. Amplitude is normal, not high. Amplitude is low, then we would say sound is low, sound is soft. If height of amplitude is high, very high, then we can say sound is very high. We can say sound is very high. From amplitude, we can find loudness. From number of frequency, we will find pitch. What is the pitch? If a frequency is low, we can say that pitch is low. If a frequency is more, in certain time, in certain distance, if a frequency is more, then we would say pitch is high. It means if there is a low pitch, voice will be fat. Hello, what is happening? Like that. Okay. And if a pitch is high, so voice will be thick. Woman speaks, so voice of woman is a high pitch. Voice of a man, voice of an adult man would be what? Pitch would be pitch of voice of adult man would be low. That's why. Hi everybody. What is happening? What is going on? This voice low pitch. Okay. So remember, from frequency we are able to find pitch. If a frequency is more, then we would say pitch is high. If a frequency is low, in certain time, in certain distance, we would say pitch is low. This low pitch is for men and high pitch is for children and women. Now, according to amplitude, we are able to find loudness. If height of amplitude is high, if a height of amplitude is high, what will happen? There will be high loud. Okay, loudness will be high. If a height of amplitude is more or less, then sound will be soft. Okay, clear? Okay, we understood parts of this. One point. This height, if this is more, then we can say it is telling what more pressure. This is height. Okay, this will tell you more pressure. If it is low, you can say pressure is low. Pressure is low. Clear? As well as you can say density will be low. For example, this. this this will tell you what here pressure is more or less. Here pressure is more or less, density is more or less. It is telling you, it is wave tough will tell you what area of rarefaction, area of rarefaction, and wave crest will tell you compression. That's why we are able to say that this is telling more pressure, this is telling more density, and this wave tough is telling what more lesser pressure as well as lesser density, because of it is a downward, that's why, and it is a upward, that's why there is a more density, there is a lesser density, because of it is a downward and it is a upward, that's why this is reason. Remember, this is way of a sound. Okay, this is way of sound. We will understand types of sound. For example, mechanical wave, non-mechanical wave, okay, longitudinal wave. Before that, I would like to tell something. For example, audible range. We are able to hear only 20 hertz, between 20 hertz and 20,000 hertz. 20 hertz, from 20 hertz till the 20,000. Only human can hear. Below the 20 hertz, animals can hear. For example, dog. Dog will hear only only number below of number of 20 hertz. Animal. Now insect, for example, bat, uh, dolphin, all this will be able to hear anything, voice of their mm, voice, any sound, they will be able to hear when amount of sound is greater, is more than 20,000 hertz. Then now you can ask, what if amount of a sound is less than 20 hertz, can human hear or not? Answer would be no, not at all. Human cannot hear sound if amount of sound is less than 20 hertz. What if sound amount of a sound is more than 20,000 hertz? Then what will happen with human? Then something crazy will happen. Ear can damage if amount of sound, amount of hertz is more than 20,000. 20,000. Remember, Hz is what hertz. We are representing it by using Hz only. That is a short but complete hertz. Now, what is a hertz? It is a SI unit of frequency. Okay, that's it. It is a SI unit of frequency. That's it. Here, what about wavelength, brother? Here, between two wave crust, distance between two wave crust, distance between two wave crust is what? Wavelength. This is wavelength. Why this is wavelength? Because here we are finding length of wave. This is wavelength. And over between two wave term, distance between two wave term. Clear? Clear. Now something else. Let's remember this curve. This curve is a disturbance. We are disturbing this by hitting something on something. That's why this line made in curve shape like that. So this will be considered. This will be known as disturbance. Okay, disturbance. Now next, mechanical waves. Now, mechanical waves and non-mechanical waves. Here, mechanical waves are those waves which need a medium. We are talking about this based on medium. If there is a medium to vibrate, then there will be mechanical waves. For example, sound wave. Non-mechanical waves are those waves which don't need any kind of a medium. For example, light. Light does not need any kind of medium to emit their light. But need sound need medium to vibrate. That's why sound wave will be considered as mechanical. Light wave will be considered as non-mechanical waves. Clear? Okay. As I explained that mm, to produce a sound, what do we need to do? We will take two objects and we will hit one object on another object. We will hit one object to another object. Then sound will come. Then now it will happen. From only one object, sound cannot come. We will hit one object to another object, then sound will come. Then sound is coming. Okay. So here can we say other medium which means object. Other object we need. That's why we are saying mechanical waves are those waves. For example, sound needs a medium. Okay. Non-mechanical waves, for example, light does not need any kind of medium. Okay. Light should have light light should be produced. Light should be produced with electricity only electricity. Without electricity, we can produce sound. Without electricity, with electricity, we can produce a sound. Without electricity, we can produce a sound. But without electricity, we cannot glow. Without electricity, bulb will not glow. Yes, is it true or not? Yes. So what are we understanding? Based on medium, mechanical waves are those waves which need medium, but non-mechanical waves don't need any kind of a medium. Now, in mechanical waves, let's see, in mechanical waves, there are two more waves. For example, transverse waves. For example, transverse waves. This is figure of a transverse waves. What is happening here? We will consider this vertical line as a y and this as a x. Clear? Now we have transverse waves. In this waves, what is happening? Always remember, always remember, particles will move in this direction because wave is moving in this direction. That's why particles not will move in this direction. Particles here wave is moving like this, upward and downward. That's why we would say particles will move upward downward because wave is moving upward downward. That's why particles will be moving upward downward. Here you can see particles here, particles here, particles here, particles here, particles here. So upward downward, upward downward. Particles are moving in this transfer. Particles are moving downward, upward, downward, upward, downward. So can you say particles are moving downward and upward? Easily you can say, isn't it? Particles are moving downward and upward because wave is moving upward and downward. That's why. Clear? That's why. And here propagation is in the straight direction. Now next something else. This is another waves. This is another. Here longitudinal. Longitudinal waves. Both looks similar. I know both looks similar, but we can define longitudinal waves in transversal wave. How? We would say what? Here remember longitudinal waves. We are understanding longitudinal waves. In this wave, what will happen? Particles will move backward and forward. Okay, like that particles will move in this longitudinal wave. Now here, both are looking same, but we can define both differently according to definition. Here we are understanding particles are moving upward and downward, and direction of propagation is in straight. Now in this we would say particles are moving backward and forward, not upward and downward. Backward and forward. Now here this wave tuff we will consider this as a rare fraction. Remember. Here we will not say that this is rare fraction because here it is wave for transverse wave. Longitudinal wave will say you that this wave top consider this wave top as a rare fraction. As you know, rare fraction is an area where particles are placed, and this is a downward. So of course it will tell you that area is less. But this high, which is a wave crest, it will tell you compression. Compression. Clear? Remember all this compression. Why? As we know, it is a compression is an area where particles are more. Now it is a high. It is the highest. That's why you will understand that here particles are high. Particles are high. Clear? Particles are high. Pressure would be high. Density would be high. Here particles are less. Density are less because particles are less. Density would be less. Pressure would be less. Clear? That's it. Remember here particles move backward and forward in direction of propagation. Direction of propagation is straight. Is what straight. Always remember. Always remember. Okay, we understood types of mechanical waves. Okay, here what's the difference? If I ask you what's the difference between them, you would say here particles are moving upward and downward, and here particles will be moving backward and forward. This is the difference between them. And one point of more you remember. One point more you remember. This will be less density as well as less pressure. This will be more density as well as more pressure because it is upward and it is a downward. Remember, brother. Crest would be more density, crest would be more pressure. Tough would be wave tough. This wave tough would be what? This wave tough would be less pressure, less density, and this wave crest would be more pressure, more density, more density. Now something else. I told you if amplitude is high, then sound will be high. If amplitude is low, sound will be low. Sound will be low. Sound will be low. If this is normal to till here only. Now sound will be medium. Okay. Let's say something else. Here sound level units in dB. Here you can see normal when we take a breath, when we take a breathing, when we take breathing, then dB would be dB would be at least 10 10 dB when we take. So sound of taking breath, sound of taking breath would be how much? Only 10 dB. We take breath. So sound of taking breath is how much? 10 dB. I'm not saying this much hard, this much hard. Only dB. Voice sound amount of a sound is very less, then we consider that in dB. For example, sound of taking breath is too much less. That's why I am saying this amount of sound is 10 dB. Now, sound of normal conservation only would be 60 dB. Normal. For example, I am talking to you in normal conservation, not loudly. So, amount of this is how much? 60 dB. 60 dB. Now, what's the difference in intensity? What's the difference in intensity and loudness? Loudness. What's the difference between them? What's the difference between them? Intensity and loudness. Are both same? Yes, there is a difference between them. Intensity will tell you when we emit a voice. For example, I am speaking like this. Here I am taking what less area, like that. I am speaking. Now like that I am speaking. Now area is very large, very widely. So my voice can go this side, this side, this side, this side. Any direction my voice can go. When I when 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 I will take something like that and I will roll, I am rolling it, and a lot of people do like that, do like that. Why? When I will speak like that, then voice quality, quality, voice of quality would be something else. Pitch is the same, amplitude is also same, but quality of a sound will be something else. This is the difference between loudness and intensity. Quality, intensity will both will tell you quality. Both will tell you quality. Now I am speaking like this. My voice is reflecting on this surface. My voice is going and is hitting on the surface, on another surface, will get reflect into another direction. Now here I am using this paper and I am speaking. Now my voice is reflecting in this, like that, and then my voice will come out. But when we do like that, then quality will be changed. Quality of the sound will be changed. Yes, it will happen. Quality will be changed. Between, what's the difference? Quality will tell. Quality, there will be quality. Yes, there will be quality. Here intensity, in the case of intensity, we cover area. In the case of intensity, for example, here I am covering area. Yes, I covered area. Now sound will be something else. Pitch is the same, amplitude is the same. Now without this I am saying, I am speaking. Pitch is the same, amplitude is also same, but quality, quality of this sound, both between this is a difference. Is a difference. Okay, this will be difference between them. This will depend on area. This will depend on area. Clear? Here, loudness, what? We hear everything. Intensity does not need any kind of movement. Here, loudness, here we response. Our ear responds to us. That loud, uh, loudness of this sound is very high, very is too low. Our ear responds. But in the case of intensity, we don't need it. We don't need to response. We don't need to response. Okay, it will depend on area. It will be depend. It cannot be depend. It can not be depend. Now, what is the frequency? What is the frequency? And what is the time period? In the case of sound, remember time period is what? One complete oscillation of one wavelength. If one wavelength, how much time one wavelength passed, so that time will be considered as time taken. For example, this much vibration passed within this time, like that. 100 vibration within 2 seconds, like that. 100 vibration. It means 100 frequency. Number of something. Number of something. So yeah, we are talking about wavelength. Number of how much number of wavelengths passed within 2 seconds. Now 2 seconds is a time period. T is equal to 2 seconds and F is equal to 100. We can find what? We have everything. We have everything. To find the frequency, we know 1 upon time period. To find the time period, we know 1 upon frequency. To find a speed, we know. To find velocity, we know frequency multiple time. Frequency multiple time will give us a speed, velocity. Velocity will give us velocity. Clear? Now let's see reflection of sound. Let's remember. Now let's understand reflection of a sound. Let's understand a reflection of a sound. Sound is coming from here. Okay, sound is coming from here. Will hit on this surface. Will hit on this surface. Of course, some sound will get reflect into this direction, into this direction. So here, this sound is something else. This sound is reflecting. So this will be a reflection of this sound. This sound is coming from device, and our ear is here. Our ear is here. We are listening. We are hearing here. Sound came from here, from this device, and it hit on this surface. It turned into different direction. Some sounds came. Some sound reached to us, to our ear. That's how sound comes to our ear. That's how sound reaches to ear by reflecting. By reflecting. That's all. Yes, it is the reflection of a sound. Okay, sound reflects. Yes, it is a true. Also remember, as we know, reflection of light, same here, laws of sound will be same. Laws of reflection of a sound on a flushed surface will be same. Will be same. If sound is coming from here, then angle will be here, and this normal line, and angle of this and angle of this both will be equal. That is what we have understood in the chapter of light. Now here, always remember, this angle will be equal to another angle. Okay, this is incidence angle and this is a reflected angle. So remember, I will be equal to R. Incidence ray and reflected ray and normal line will lie on same plane. On same plane. Now let's see what is echo. Now let's see what is echo. What do we think? Echo is a voice. Echo is a sound. Whatever we hear, echo is a sound. Okay. But it is a what? A reflected sound. Okay, I am not saying incident sound. Echo is a reflected, but after one, a sound will hit on a surface, then that reflected sound will reach to our ear. Not I am talking about multiple reflection, only one reflection. Only one reflection of a sound. Only one reflection of a sound we will consider. Remember, only one reflection of a sound will be echo. How is echo produced? When a sound comes and hits on the surface and then it turns into another direction, just this turning of a sound is a reflection, and this reflection sound will be echo. Remember, echo is just a reflected, one reflected, you can say, one reflected ray. Okay, how is the sound of echo? I say, how are you, how are you, how are you, how are you, like that. When I say how are you, how are you, how are you, how are you, it is echo. We say one time and we hear 2-3 times. Okay, we say one time, we hear 1-2-3 times, one time, 2 times, our same voice. It happens because of reflection of sound. It happens because of reflection of sound. Okay. Here remember, particles will obstruct. Particles will try to stop. Always remember, particles will try to stop sound. That's why sometimes our sound. That's why sound we cannot hear sound. We see after just few seconds. Okay. A reflected sound we will be able to hear after 0.1 second. Always remember, we will be able to hear reflected sound after 0.1 second. Always. Okay. Echo is just one reflected sound. And sound, how is the echo sound? I told you. What's happening? What's happening? What's happening? What's happening? Like that. Echo is a sound where we speak 1 times and we hear 2 or 3 times. Because of a reflection of sound. That's clear. And we get response reflected ray within a 0.1 second. Within 0.1 second. Also. Now next, this was also a type of a sound. It is a sound, but this is a something difference. Something difference, which means sound will come out from a device only one time, and then we will hear two, three times the same sound. This is echo. Now next is what? Only one time in this only we will listen only one time after 0.1 second. Reversion is also a sound, but it will happen when there are happening how much there are multiple reflection of a sounds, then reversion sound will come out. Okay, then multiple reflection of a sound will come out from a device. Are you understanding? Reversion is a what? Reversion happens when there are multiple reflections of a sound multiple reflection. Remember, yes, you are correct. Remain, sir. Sound came here, and then it will hit on the surface. Then it will reflect. Then there is also a object. Then it will turn into an direction. There is another surface. Then again it will turn into another direction. We have one, two, three reflections of only this sound. That's why this will form reverberation. Okay, this will form reverberation sound. Echo is only one reflected sound. This only. This is the echo. If we are here, then only one time we will listen. If we are here, then only we will hear this sound only one time. If we are here, then sound will come to us like that. By reflecting 3 or 4 times. Many times, you can say, many times. Sometimes we hear a lot of voice of only one original voice. Why it happens? Because of there are a lot of reflectors objects. Yes, there are a lot of reflector objects. Now here we have backend. We have carpet. All these are things that observe. All this will observe sound. Will observe. That's why it is said that all this, any object which is observing sound, will be known as bad conductors, because it is because sound will not reflect, will not take turn by hitting on this object, because it will observe. This object will observe. Then how will incidence? How will sound will turn into another direction after hitting on this object? No, because it is observing. That's why. Now, break this board, this board, board, this board. Otherwise, you can say this wall. These are bad reflectors. These are bad reflectors. Any objects which are not able to observe sound. For example, I cannot observe sound. Sound will come, will hit on me, and then it will turn into a radar. But packet you can take. You can take this sound will come, and some sound will this will observe. Some sound this will observe. Even it is said here. This is the best example. This is the best example. Here you can see thickness of this. Thickness of this is more. Now this will observe more sound. It will be able to observe sound. Okay. So this is observed, and we can say it can observe sound. But what about wall? Wall will not be able to observe anyhow what sound. Wall. Iron is a pure bad reflector. Any object where on which reflection cannot happen. Any object on which reflection cannot happen, we will say that object is bad reflector. Any object on which reflection can happen. Any object which cannot observe sound, so that object is a good reflector. Any object which can observe sound, that object is bad reflector. Bad reflector. Did you understand? One more point. Very interesting for me. Solid, liquid, and gas. Solid, liquid, and gas. We have solid materials. Now we are understanding a speed of a sound. In solid material, a speed of a sound will be more. Always remember. I will give you a real example. Always remember, in solid material, a speed of light will be more. In liquid material, for let's say a speed of a sound is how much? 7 meter per second. Let's say. Now 7 meters per second. This is in this. Now in liquid material, a speed of a sound will be less. Will be normal, you can say. Will be normal, not less completely. Will be normal. But in gas will be almost less. Yes. In this completely speed, in this normal speed, in this very less speed. So in gas where particles try to obstruct, try to be what barrier for sound. Yes, when lightning you see when weather is not well, then you see what lightning. What is it? Lightning. Okay, like that. You see. So here we see lightning. First of all, we see lightning. Then sound reaches to our eye. after some time. It happens because gas is trying to, particles in the sky are trying to stop this sound which is coming after after lightning, but we hear after some time. And it is happening because light of speed in the air is less, and we understood here in the gas where particles are present, and particles try to obstruct, try to block, but they are not able to stop the sound which is coming through particles, through gas. They are not able to stop completely. But a speed of a sound decrease in a speed of a sound decrease in gas. After sometimes we are able to hear sound. Clear? That's all. That's all.